Alright, so this is a unit circle in a nutshell. So for us to cover like what your sine and cosine are, it's a good idea to review 45, 45, 90 triangles. So the ratio of the leg to hypotenuse in a 45, 45, 90 is 1 to 1 to the square root of 2. And you can confirm that here using Pythagorean theorem. So what that means is, since the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, the sine of a 45-degree angle is 1 over square root of 2. Problem with that is we have square root of 2 in the denominator, so let's rationalize that denominator. So you simplify that, multiply by square root of 2 on top and the bottom. You end up getting the sine of 45 is square root of 2 over 2. For cosine of a 45-degree angle, it ends up being the same thing. You know, you do adjacent over hypotenuse this time, but your opposite and adjacent legs are the same. So for sine and cosine, you get square root of 2 over 2 for a 45-degree angle. For a 30, 60, 90 triangle, recall that the ratio of the size of the small leg to the medium leg to the hypotenuse is a ratio of 1 to square root of 3 to 2. So the sine of a 30-degree angle, we're doing opposite over hypotenuse. So the opposite to the 30-degree angle is 1, hypotenuse is 2, so sine of a 30-degree angle is 1/2. Cosine of a 30-degree angle is going to be adjacent over hypotenuse, so that one is square root of 3 over the hypotenuse 2, so cosine of 30 degrees is square root of 3 over 2. When you take the sine and cosine of a 60-degree angle, they kind of swap places. For sine of 60, you get square root of 3 over 2. Cosine of 60, you get 1/2. Now, if we want to plug this into our unit circle, first of all, let's recall that the x-coordinate in a unit circle is your cosine of that angle. The y-coordinate in a unit circle is your sine of that angle. So we fill in our angles: 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120, 135, so on and so forth. So if you see there's a difference of either 30 or 15 between these, and it kind of maintains that pattern. Also, it's good to recall that the conversion from radians to degrees, for every 1 radian, you have 180 degrees. So if you're ever stuck on, for instance, I got stuck on 60 degrees, how many radians is that? Well, I do proportion. 60 over I don't know how many radians is equal to 180 degrees over pi. And you cross multiply, and you can solve, you get pi over 3. So you could just use fractions. You can use your calculator if you want to convert that, or just do it by hand. So we write out all our degrees here, and then we write out the equivalent radian measurement next to them, and you can use either one. Get used to writing just the radian measurements, because you're going to use that a lot more often. So again, if you get stuck, you can always write your proportions where 180 degrees is equal to pi, so you can cross multiply and solve for each degree measurement, find out how many pi radians that measure equates to. Alright, so now that we almost have all our pi radians filled out, we can get all the way around the circle. Remember, for your x-coordinate in this unit circle, and a unit circle is a circle with a radius of 1. That's why we used triangles when we were doing those 45, 45, 90, and 30, 60, 90. We use triangles with hypotenuse of 1, because you can actually sort of draw right triangles inside of these circles here. So your x-coordinate for the 0-degree angle, here, well, we do cosine of 0 for the x-coordinate, sine of 0 for the y. The cosine of 0 is 1, sine of 0 is 0, so you get coordinates 1, 0. For 30 degrees, we do our x-coordinate is cosine of 30 degrees. Our y-coordinate is sine of 30 degrees. You can recall up here, cosine of 30 degrees is square root of 3 over 2. Sine of 30 degrees is 1/2. So you get square root of 3 over 2 as your x-coordinate, 1/2 as your y-coordinate. For 45 degrees, both sine and cosine had values of square root of 2 over 2. So those coordinates are square root of 2 over 2. And then for 60 degrees, remember, it kind of trades places with 30 degrees. So you get 1/2 square root of 3 over 2. For every other degree, you only need to know your first quadrant. Memorize that. Everything else is just reflected about the x-axis. So if you notice, the ones in our second quadrant are the exact same numbers, except they're across from it, and the x values are negative. In your third quadrant, exact same numbers, except in the third quadrant, both your x and your y are negative, so both of those are going to be negative. You just reflect across. In the fourth quadrant, your x is positive, but your y-coordinate is negative, so you just reflect from the first quadrant across the x-axis, and you make your y-coordinates negative. Alright, so you go ahead, just memorize your first quadrant, reflect everything else, and you should be good to go. So that's the unit circle in a nutshell.